Welcome back to topic 43 for Algebra 2, inverse variation. In part 1, we're going to review direct variation and apply direct variation to solve some examples. What is direct variation? A function that is represented specifically in the form y equals k times x. Now k is called the constant of variation. And k specifically is non-zero. Because if k was 0, then y would also be 0. Now when we read direct variation, we read it as y varies directly as x. And you will actually see this phrase often in word problems. Now specifically when we graph direct variation, it's linear. So the graph passes through the origin. In other words, it has a y-intercept of 0. Now let's look into some examples of direct variation as well as some non-examples. First example. We might see something like y equals 2x. However, a non-direct variation would be something like y equals 2x minus 1. Here we'd have a y-intercept at -1 instead of at 0. If we have y equals -1/2 x, our constant could be positive or negative as well as a whole number or a fraction. A non-example would be something like y equals -1/2 x plus 2. And lastly, we could have something like y equals 3/4 x, but not y equals 3/4 x plus 5. Another word problem we might encounter is something along the lines of the variable y varies directly with x. So we already know we're dealing with direct variation because it literally says it here in the problem. Now if x equals -2 when y equals 8, then what is x when y is 18? So we can start with our template here. Y equals k times x. We'll plug in for x and y and solve for k. These problems are kind of like two-parters. So let's try it first. We'll plug in 8 for y, keep k as a variable, and plug in -2. Now this is a one-step equation in order to solve for k. We can divide both sides by -2, and k is -4. Now we can rewrite it in order to get our direct variation equation. Y equals -4x. So all we did here was we just plugged in -4 into the k spot. Part 2, we're going to take this new equation and plug in our other part for y. And I just wrote y. Ooh, goodness. So if y is 18, we're going to plug in 18 for y, -4 for k, and we have to solve for x. So now I can divide both sides by -4. And I can also simplify this. So x equals 18 divided by -4, or -9/2. Now you might see something along the lines of more traditional word problem. The number of words Capri types varies directly with the amount of time she spends typing. So here we're not dealing with variables such as x and y, but if we read the problem closely, we know we have the number of words that Capri types with the amount of time she spends. So if this varies directly, we can rewrite it as W for words equals our constant of variation times the time. Now we can plug in. If she types 300 words in 6 minutes, how long will it take her to type 525 words? So we'll plug in 300 for W equals K times 6. Now we can divide both sides by 6 in order to solve for K. K equals 50. And now we can rewrite our equation to be W equals 50 times T. Rewriting it, we want to know how long, so we want to find T here, it will take her to type 525 words. So we'll plug in 525 for W equals 50 times T. Now we can divide up both sides by 50, and T will equal 10.5. So it would take Capri 10.5, now our unit is minutes, to type 525 words. And that is part 1 of topic 43 for Algebra 2 on inverse variation.